Hi guys, this video is intended to support those of you who are beginners in the field of data science, yet you feel really keen on solving the case on Sofia Air pollution. So, the very first thing I will do is import my data. However, it is always a good practice just to clean up the global environment prior to importing new data. Also, setting the working directory where datasets are saved is a good practice. Okay, then you might import data on citizen science air quality measurements and also on topography data for Sofia. Okay, I would like to emphasize the fact that it is a good practice just to set up several opportunities for NA strings, such as an empty cell is treated as NA, space is treated as NA, etc. Also, the parameter strings as factors is set here to false. This means that strings are treated as strings rather than as factors. As soon as you import the data in the global environment, the second step is just to make sure everything with the variables class is correct. For this purpose, I would first create a new object where I would record information on variables names and classes. So let's do this first for season measurements on Sofia Air pollution for 2017. Okay, let's have a quick look at the output. So you might note the output is a table. The first column represents variables in this dataset, and the second column represents information on variables classes. So you might well know the dataset on citizens' air quality measurements consists of time variable. An issue is that it is treated as character, so we would fix this in a minute. Then you have geo hash. This is unique information on the citizen station. Then have P1 and P2. These are particular measurements on air quality. Rest of the data considers weather characteristics. Okay, let's quickly inspect rest of the datasets currently imported. So let's view data structure for the second dataset air quality measurements for 2018. Once again, we have the same variables and the same problem with the class of the time variable. Last, let's just quickly see variables in the Sofia graphic data. So have latitude, longitude, and elevation. All variables are of class numeric, so that's fine. Now, as soon as we've identified the issue, it's time to fix it. However, prior to fixing this issue, it is a good idea just to have a quick view of, let's say, the first 10 observations on the time variable, as they are described at the first 10 unique observations on the time variable. So the date and time is year, that you have month, day, and the time is hour, seconds. By data is sampled on hourly basis. So a really convenient library is lubridate. So using this function at corresponds type information on date and time is recorded. I will just fix the issue with classes. Okay, so make a check that now everything is correct. Okay, now variable is treated as time. Do the same for the other date. Okay, now that we have fixed this issue, the next step comes down to analyzing data by stations. In particular, what you have is information on geohash. Each particular station is characterized by its own geohash. So let's see, for 2018 we have more than 1000, and for 2017 they are more than 300. Okay, so the next step in our analysis is to have an idea on observations available for every station. I would summarize this information in a new project. So, by the way, for this purpose, I will use this library. It is particularly useful with characteristics. So first, let's summarize data for 2017. Group data by geocache and provide me the number of observations for each geohash. Do the same for 2018. Okay, now let's quickly view what is the output. Let's say for 2018. Okay, so you might know that we have geohash and number of available observations. So if you order data, you might know that alright, there are several stations with just 1 or 4 observations, so probably analyzing further information for those stations is not worth it. Okay, then obviously there are differences in geohashes represented in the datasets for 2017 and 2018. In particular, what I noticed, there are altogether 11 stations that are observed in 2017 but are not observed in 2018. As soon as we are to pass air pollution by stations, it makes sense just to analyze data that is represented also in 2018. So these are the stations listed in 2017 but in 2018. So altogether 11 stations amounting to less than 800 observations. So I think I'm to just remove the stations. And now I might just merge the two data sets by binding rows. Okay. Currently, you may note there are a lot of auxiliary variables here. I wouldn't use anymore, so I just clean up what I have is the merged dataset on air pollution for Sofia and topography data. Okay, so I consider that step 3. We might move on with step 4. This is to provide summary on availability of data by stations. First of all, let's see if there are any geohashes. 4 of them are missing. So this is just more sample. Okay. As a next step, just make summary by geohashes using the data. Of course, grouping by geohashes. So I would like to summarize the number of observations for each station. Then for first date of observation, the last date of observation by this station, and the period which they were observed in days. Then I would simply arrange by days observations and your hash. Now let's have a look at the output. Okay, so obviously you might know there are stations observed just once, so we have complete days of observations. Obviously, I would use this information when I filter stations in time. I mean, for example, I wouldn't use further this station for my analysis as it was observed just once to predict what's going on with their quality at this station. Okay. Now, step 5. It is just now we have an idea on stations, and it is time to check how they are represented on the map. For this purpose, first I need to transform the geohash into latitude and longitude, and there is a library. Okay, so the name of the library is hash. Okay, so the next thing I would do is just add more variables here that contain information on latitude and longitude associated with the geohash, also control information errors. Okay, so use the gh decode function. Okay, now have a look. We have is not just the geohash but also its respective latitude, longitude. Of course, you have some error measurements. Okay. The next thing is to create a map object. So for this purpose, we'll use our world library. I'm creating a new map. This is an object just to illustrate what is the class of this object. It is spatial polygons data frame. Then I would open up a window, a chart window, okay, and I would Bulgaria, okay. So here in brackets you might see approximate boundaries of longitude and latitude for Bulgaria. Okay, so let's make the plot now. Okay, here it is. Now I first visualize stations provided in the Sofia topo data. Then I will provide information on stations. So just let's first put with red points topography data. Okay, so this rectangle right here denotes Sofia. Okay. Then I would illustrate points on observations. For citizen science stations, you might note they are spread over Bulgaria, so I would restrict my analysis only to the points belonging to this rectangular that provides roughly the boundary of Sofia. And this is actually the next step of my analysis. So just open up step 6. This is filter stations by space and time. For convenience, I would rename columns of topo data. Okay, and then filtering by space. It is, by the way, a really simple filter. So what I say is filter the grouped geohash data, okay, using as upper and lower bounds of latitude and longitude contained in the Sofia topo dataset. Okay, The next step is summarize the availability stations in Sofia. In particular, what I do here is just have a look on distribution of this for the stations belonging in the Sofia region. You might well note that there are just few stations with complete records for 2017 and 2018. There are a lot of stations with, let's say, less than 50 complete days of observation. So my next task is just to decide on how many days I will use as a benchmark for filtering data time. By the way, apart for looking at information visually, it is always to have a look at the core descriptive statistics. So let's look at them. Obviously, we have more than 500, actually it is 568 stations. The maximum number of days observed is 343. This is less than a year. What else? You might well note that the minimum value is 0, so probably we clean those stations now. It is also informative if you want to have a look at distribution, looking at the 5th percentile, 10th percentile, etc. So let's say at the 5th percentile, information is 16.38. This means that the first 5% of stations are with less than 17 complete days. This means if I set up a boundary of, let's say, I would like to have at least complete days of observations, I would clean less than 5% of data availability. Okay, so this is the filter I went. It's really a basic filter, so it might be refined. Result for this process, I just put a filter of 7 complete days and I'll get 168 patients. Okay. The last step I would do is a new object where I have the information only on state would be further line. Alright, so this is the list of states I will analyze further. And now I will filter the entire data frame on citizen science air quality measurements. I would restrict the data on 2 stations in Sofia and that have at least 7 complete days of population. Of course, I would say for now because this is the end of week 1. However, I would clean up auxiliary information. Okay, save my global environment in a file. So that's it for week 1. Next week we move on with the steps for week 2. Thanks for watching. Bye.